Hey everyone, welcome back to the channel. In today's video, we'll be exploring abstract classes in Python, a concept that often shows up in technical interviews. Abstract classes are essential for designing complex systems and enforcing certain methods in your code. We'll break down what abstract classes are, why they're used, and go over some practical examples that will help you understand how to apply them in real world scenarios. Whether you're prepping for an interview or just looking to sharpen your Python skills, this video will give you a solid grasp of abstract classes. Definition. In Python, abstract classes are used as a blueprint for other classes and can't be instantiated on their own. Think of them as templates where certain methods or behaviors are defined, but the specific implementation is left to the subclasses. This ensures that when you create a new class from the abstract class, you are forced to implement certain methods, making sure the structure is consistent across related classes. To create an abstract class in Python, you use the abs module and specifically the abstract method decorator to mark methods that must be overridden in any subclass. For example, you might define an abstract class for shapes, and every subclass like a circle or square would have to implement methods like area or perimeter. This keeps your code well structured and enforces a clear contract for subclasses, ensuring that they meet certain requirements. The syntax is straightforward. You define an abstract class by inheriting from ABC. Then use the abstract method decorator to define methods that must be implemented by any subclass. When you attempt to instantiate the subclass, those abstract methods will need to be fully defined, ensuring everything works as expected. Now that we've covered what abstract classes are and how they work in Python, let's dive into a practical example to see them in action. We'll create an abstract class with some abstract methods and then implement those methods in a subclass. This will give you a clear idea of how abstract classes enforce structure and how they can be used in real world scenarios. Let's jump right into the code. 1. Basic abstract class example. Question: write an abstract class animal with an abstract method make underscore sound. Create two subclasses dog and cat that implement the make underscore sound method. In this example, we're exploring the concept of abstract classes and methods in Python using the animal, dog, and cat classes. The animal class is defined as an abstract class by inheriting from ABC abstract base class. Abstract classes in Python act as blueprints for other classes and cannot be instantiated on their own. The animal class also defines an abstract method make underscore sound using the abstract method decorator. This method has no implementation in the animal class and serves as a placeholder that must be implemented by any subclass of animal. The dog and cat classes inherit from animal and are required to provide their own implementation of the make underscore sound method. The dog class implements make underscore sound to return woof, simulating the sound a dog makes, while the cat class implements it to return meow, representing a cat sound. This structure ensures that every subclass of animal will have a make underscore sound method but allows each subclass to define its own version of that method. This is a key feature of object-oriented programming called polymorphism, where different classes can have methods with the same name but different behaviors. When we create instances of the dog and cat classes and call them make underscore sound methods, Python calls the specific implementation in the subclass. The dog object returns wolf and the cat object returns meow, showcasing how abstract classes enforce consistent method structure while enabling flexibility in implementation. This design pattern is particularly useful when you have a group of related classes that must implement certain methods but may behave differently. 2. Abstract class with constructor. Question: write an abstract class shape with an abstract method area. Use a constructor to initialize common properties in the abstract class and implement area in the circle and rectangle subclasses. In this example, we are using abstract classes and inheritance to model different types of shapes, specifically circles and rectangles, while sharing a common structure. The shape class is an abstract class, meaning it serves as a blueprint for all shapes but cannot be instantiated directly. It includes a common attribute name and defines an abstract method area. The abstract method forces any subclass of shape to implement its own version of the area method, ensuring that each shape defines how its area is calculated. The circle and rectangle classes both inherit from shape, meaning they must provide their own implementation of the area method. The circle class calculates the area using the formula for the area of a circle, pi multiplied by the radius squared, while the rectangle class calculates the area using the formula width multiplied by height. Both subclasses call the parent class's constructor super dot underscore underscore init to initialize the common name attribute, setting it to circle or rectangle respectively. This use of inheritance allows for code reuse and provides a consistent way to handle all shapes while allowing for flexibility in how each shape's area. When we create instances of circle and rectangle, we provide specific dimensions like the radius for a circle or the width and height for a rectangle. The area method is then called for each shape to calculate its area. Additionally, the name attribute from the parent class is used to print the name of the shape alongside its calculated area. This example illustrates how abstract classes, inheritance, and polymorphism allow us to create a scalable and organized structure for handling different shapes while ensuring that each subclass provides its own specific behavior for calculating the area. 3. Abstract class with multiple subclasses. Question: create an abstract class vehicle with an abstract method max underscore speed. Implement this method in the subclasses car, bike, and truck. In this example, we are utilizing abstract classes and method implementation in Python to model different types of vehicles. The vehicle class is an abstract base class ABC that defines a common structure for all vehicles by using an abstract method max underscore speed. This method has no implementation in the vehicle class itself, as its purpose is to serve as a template for any subclass that inherits from vehicle. The subclasses are required to provide their own implementation of max underscore speed to specify the maximum speed of the respective vehicle. We have three subclasses: car, bike, and truck, each inheriting from vehicle. In each of these subclasses, the max underscore speed method is implemented to return the specific maximum speed for that type of vehicle. For instance, the car class sets the maximum speed to 180 km/h, the bike class sets it to 120 km/h, and the truck class sets it to 80 km/h. This ensures that each type of vehicle has a distinct implementation while maintaining the same interface. When we test the code by creating instances of car, bike, and truck and calling the max underscore speed methods, we can see how each subclass implements the abstract method differently. The abstract class vehicle enforces a consistent structure while the subclasses provide specialized behavior for each vehicle. This approach demonstrates the power of abstraction and polymorphism in object-oriented programming, allowing for flexible yet organized code that is easy to extend with new vehicle types, each implementing their own version of max underscore speed. 4. Abstract class with abstract properties. Question: create an abstract class employee with an abstract property salary and an abstract method get underscore details. Implement the subclasses manager and developer with the required properties and methods. In this example, we are using an abstract base class ABC called employee to create a blueprint for different types of employees such as manager and developer. The employee class defines two abstract members, a property salary and a method get underscore details. Abstract properties and methods must be implemented by any subclass that inherits from employee, ensuring that each employee type defines how to retrieve its salary and provide its details. The manager class inherits from employee and implements the required salary property and get underscore details method. The constructor for manager takes a name and a salary as arguments, and it stores the salary in a protected attribute underscore salary, which is then accessed via the salary property. The get underscore details method returns a formatted string containing the manager's name and salary. Similarly, the developer class also inherits from employee and implements the salary property and get underscore details method. Like manager, the constructor for developer takes a name and salary and it stores the salary in underscore salary accessed through the salary property. The get underscore details method returns the developer's name and salary in a formatted string. When we create instances of manager and developer, each class provides its own implementation of get underscore details, ensuring that the abstract methods defined in employee are correctly implemented. This structure demonstrates the power of abstraction and polymorphism in object-oriented programming, allowing for consistent behavior through salary and get underscore details while letting each subclass define specific details. The use of properties for salary ensures encapsulation, providing a clean way to access the salary without directly exposing the underlying attribute. 5. Abstract class with abstract methods and properties. Question: create an abstract class shaped with an abstract property area and an abstract method get underscore details. Implement the subclasses circle and rectangle, providing the required implementations for the abstract property and method. In this example, we are exploring abstract classes, abstract properties, and how they can be implemented in Python using two subclasses: consultant and full-time employee. The abstract base class employee defines a blueprint for different types of employees, requiring that any subclass must implement two key members: an abstract property salary and an abstract method get underscore details. Abstract properties and methods cannot be directly instantiated in the employee class. Instead, they act as placeholders that must be overridden by any subclass. The consultant class inherits from employee and provides a specific implementation for the salary property and the get underscore details method. In this case, a consultant salary is calculated based on an hourly rate and the number of hours worked. The formula hourly underscore rate hours underscore work dynamically computes the salary. The get underscore details method returns a formatted string showing the consultant's name and their calculated salary. The full-time employee class also inherits from employee and implements the abstract property and method, but with a different approach. A full-time employee's salary is fixed and provided as an annual salary, which is set during object initialization. The salary property simply returns this fixed value. Similarly, the get underscore details method returns a string containing the full-time employee's name and salary. When testing the classes, we create instances of both consultant and full-time employee. For the consultant, the salary is calculated by multiplying the hourly rate by the hours worked, e.g., 50,168,000. For the full-time employee, the salary is fixed at 90000. Calling the get underscore details method for both instances prints the respective details. This structure demonstrates how abstract classes and properties can enforce a consistent structure across subclasses while allowing each subclass to define its own behavior for calculating salary and displaying employee disarray. This approach is highly flexible and scalable, as additional employee types can be easily added by implementing the abstract methods and properties defined in the employee class. And that wraps up our deep dive into abstract classes in Python. I hope these examples help you better understand how to work with abstract classes and why they're so useful in designing structured, reusable code. If you found this video helpful, don't forget to hit the like button, subscribe for more interview prep content, and turn on the notifications so you don't miss out on future videos. Thanks for watching and good luck with your coding journey. See you in the next one.